Hello, welcome back to Proximity Math. I'm gonna go over the 2005 Aime Ii number 4. Find the number of positive integers that are divisors of at least 1 of 10 to the 10, 15 to the 7th, or 18 to the 11th. Okay, so we want the number of positive integers which are divisors of at least one of these. Okay. Okay. Okay, so what we want to find. So we want to find the number of divisors of 10 to the 10, then 15 to the 7, then 18 to the 11, and then we're going to use principle of inclusion and exclusion to not overcount, or to subtract overcounting. Alright, so then first we'll find the number of divisors of 10 to the 10, which is 2 to the 10, and then 15 to the 7 is 3 to the 7 times 5 to the 7, 18 to the 11, 18 is 2 times 3 squared, which would mean it's 2 to the 11 times 3 to the 22, because it's 3 squared to the 11. Alright, so the number of divisors of this 10 to the 10 would be 121 by the factor formula. Because, yeah, you should know how to find the number of divisors of a number using its by factorization. You add 1 to this, and then you add 1 to each of the exponents and multiply them. So this is 10 plus 1 times 10 plus 1 is 121. Alright, and then similarly for this one, we have 8 times 8, which is 64. And for this one, we have 12 times 23, 12 times 23, which is 276, right? Wait. 12 times 23. Yeah, okay. Now, first of all, we're gonna add these to get each of the cases. And now we have to subtract the pairwise overcounts. So like the number of divisors common to the two of these numbers. So between these two, it would be the only common factor is 5 to the 7. So if you take the GCD of these two numbers, you would get 5 to the 7, and that gives us 8 factors. From these two, we get only 3 is common, and the highest exponent is 3 to the 7. So 3 to the 7 gives 8 more factors. Subtract. And then from these two, we clearly have 2 as the common factor, and 2 to the 10 goes into both of them, which means there's 11 common factors. Alright, and now we have to add the number of factors common to all 3 of them, which you might have guessed is only the factor 1, because there's no prime factor which is common to all 3 of these. Like this one has no 3, this one has no 2, and this one has no 5. So you know that? And therefore, the only factor that's common to all of them is 1. And make sure you, if this was a case where there's more than 3 numbers, then you would have to add 1 the correct number of times. I think so. Because if there were 4 numbers, you would be adding 1 4 times, and then you would be subtracting 1. 4 choose 2 is 6 times. So you have to add That would give you subtracting 1 twice. You have to add 1 3 times instead in that case. So be careful when you're using principle of inclusion exclusion. But anyway, for this case, we can just do simple arithmetic and get our answer 185. And then so minus 10 instead. This is minus 16 minus 26. This gives us cancels out. Plus 250. And this gives us 435. 100 is 35 plus 300. Okay. And 435 is our final answer. All right. Thanks for watching, and I hope this helped you.